this session, we will cover about intro to protocol testing. So in this, we'll see what is protocol testing, understanding protocol testing, various artifacts like test plan, test cases, and other things which need to specify the test plan and type of protocol testing. So, what is protocol testing? So, till now, what we discussed, so we got to know for a proper functionality of the networking, we need several kind of protocols. So, what we discussed about some switching and routing protocols. So, routing protocol, which is configured in the routers to learn the routes dynamically. There is a way of configuring it statically also. So static also we can consider it as protocol. Similarly, in switching we have discussed VLAN, STP. Those things also we can consider it as protocol. So protocol is a set of rules which is followed to get a proper functionality of a device to get proper functionality. So the protocol testing is a cumulative term used by communication industry. So what is protocol? Protocol is set of rules. So if we define a set of rules, if we if two persons are communicating, one is following a different rule, another person is following a different rule, so they will not reach to a single point, they will not conclude to a single point. So that's why there is a protocol. So when two are communicating, they both will follow same protocol, then only they can reach to a conclusion. So similarly, here in networking also we'll have protocols. So if we configure one protocol, suppose we are talking about router, we configured protocol X, or suppose one protocol we'll call it as OSPF. We configured in router A and router B, we configured OSPF. So both routers now will follow same set of rules. That is why we have protocol. So now, what is this protocol testing? In a simple way we can understand is, for example, if we install the routing protocol, there will be set of functionality which is expected from that. So the set of functionalities which is expected from that will test. That will call it as protocol testing. For example, what OSPF should do, or what a routing protocol should do, it should help other router to learn the routes. So now what we'll do, we'll configure it and we'll check whether we are able to learn the route by using this routing protocol or not. If we are able to learn, we'll say protocol testing is passed. If we are not able to learn, we'll tell it as fail. So in a simple language, this is protocol testing. Now, the protocol testing is a cumulative term used by the communication industry or organization for the testing of different protocols in the domains of VoIP, wireless, switching and routing. So we'll not discuss about VoIP, wireless, switching and routing, but in VoIP, wireless also we have protocols. So, but here what we are doing, we are discussing about switching and routing. So what we are going to discuss here is protocols which is related to switching and routing. So wherever we are saying protocol testing, here we'll refer it as, we want to tell it as switching and routing protocol testing. So in the protocol testing, we test the structure of packets which are sent over a network using protocol testing tools. So what we'll do, any protocol, what it does, it will send some sets of packets, some sets of frame. Okay, what we'll do, we'll send some set of things and we'll check whether it's working properly or not. Now, during the test, routers and switches are involved, which form the part of devices or products under test. So what we'll do, suppose we have three devices, three routers. Now, one will be, suppose, for example, we are taking an example of spanning tree protocol. So spanning tree protocol, as we discussed, there will be one root and others are non-root bridges. So one will be root bridge. Now, suppose we want to test only root bridge functionalities, like how it is behaving, how it is working, how it is sending the frame, how it is receiving the frame. So the one which you found as root, that will be our device under test. Why? Because here we are just checking the root bridge functionalities. Okay, we'll discuss this device under test on more details. In more details. Now, routers we can imagine as a bus, which is used for the transportation, and routing protocol as a traffic signals. So, what bus will travel, but it has to follow the traffic signal. So, traffic signal will define your rules. When you have to start, when you have to stop, you have to take a right, you have to take a left. So, those things are decided by a traffic signal. So this is the summary of protocol testing. Is like we are testing the functionalities of the particular protocol, whether it is working fine or the way it should behave, whether it is behaving or not, and then we'll send packet, we'll try to send frame or packets, and we'll check whether it is behaving in the proper way or not. So as we already discussed, software protocols set of rules and constraints that each computer will obey when communicating with each other over a network. So why the software protocol has come into picture, again I told, when two persons, again I'm telling it, and I already told, when two persons are communicating, one is speaking in a different language, another is speaking in a different language. So one is following as a different rule, second is following in a different rule. So it is very difficult to communicate. So these rules, what will do, software protocols are the common set of rules and constraints that each computer will obey when communicating with each other. So when two computers are communicating, they have to obey this software protocol. They have to obey the set of rules defined by these software protocols. Now, these rules define the data and its format that should be followed by all computers during data transfer through a network. The protocol can be categorized. So nothing. It is something like whatever packet you are sending or whatever data you are sending, that will be sent according to this software protocols. So whatever software protocols has defined, that only will be sent when you are communicating with a different device. Now, protocol can be categorized into two categories: routed protocol and routing protocol. So as we already discussed about routing protocol, what is routing protocol? So routing protocol was, when we discussed, it was helping us to determine the routes for the router. When two routers are there, one router will share their route to other router. So with that, it is able to take the decision what is the best path to reach to one destination. That is a routing protocol. What is routed protocol? So routed protocol are a set of rules which are obeyed by the computer in order to send the user data from one network to another network. So it is if you want to send from one network to other network, if you want to send, we have to follow a rule. That is routed protocol. So whenever you are doing this transmission from one network to another network, this routed protocol will come into picture. But routing protocol may come, may not come. Even though you don't have routing protocol, you can communicate. But if you don't have routed protocol, you cannot communicate. So routed protocol examples are IP, IPX, AppleTalk. It is applicable to the user traffic such as web traffic, emails, file transfer, etc. Routing protocol are network set of rules which help to determine routes for the routers. We already have seen this. So it comes into play when we need to determine which routing data packets would be sent between routers. So RIP, IGRP, EIGRP. So by using routed protocol, what you will do, you will send the actual data. But by using routing protocol, you will share only the routing information. So there is difference. If that is a major difference, you can say in the IP, when you are sending any data you are sending, what you need, if it is across the network, you need an IP network. You need a IP header. Along with that, your data need to be attached down the header. But here in routing protocol, what you will share, it will not be what we can say, it will not be actual data, but in routing protocol, what you will share the routing information. We'll go to next slide. So scope of protocol testing. So in most of the organization which is working with this networking devices, they will perform this protocol testing, such as Cisco and Juniper. So Cisco, most of you would have heard. Juniper, most of you would have heard. So routers, modems, switches, wireless access points. The protocol testing for these devices involves checking of here they have mentioned EIGRP or OSPF, but it is checking of various protocols. You can say it is not only these two protocols, there is numerous protocols. So when you will say there is numerous number of protocols supported on these devices, so for everything they will do this protocol testing. So what is the aim of doing this protocol testing? One thing is, like, suppose for example you are having now Windows 8 you are using, after that you have gone to Windows 9 or Windows 10. So what you are doing, Windows 8 was supporting some 10 functionalities. Now when you went to Windows 10, all those 10 things are supported. You need to check all those 10 things are supported. Along with that, if you will say that in Windows 10 I have enhanced and now there is 10 more new functionalities. So 10 old plus 10 new functionalities. So what you will do, 10 previous things you will test, along with that you will check 10 new functionalities as well. Okay, so similarly in protocol testing also, what they will do in Cisco Juniper also, every time they will enhance their software, their OS, which is running on Cisco or Juniper devices or any other networking vendor devices. So what they will do, every time when they are enhancing this their OS, suppose for example first time it is supporting some 10 protocols, next time it is supporting 5 more protocols. So for every protocol they will perform this protocol testing. So suppose in previous version X, it was supporting 10 protocol. In the new version Y, now it is supporting 15 protocols. So now all 15 protocols, you have to perform this protocol testing. So in the protocol testing, what you will do, everything related to that protocol you will test to ensure that all the functionalities are working fine. And if suppose in one protocol some particular functionality is not working fine, you have to report a bug. That is the work of a tester. So when you'll report a bug, with that bug, developer will get to know, okay, this functionality is not working fine. Then he will go into the code and he will see what was wrong in the coding, that this particular functionality is not working in this protocol. Then he will correct it and it will come back to you again. Then again, what you have to do, you have to retest it. If it is working fine, you will give it approval like, okay, this particular functionality is working fine. Yet if it is not working fine, after changes from the developer also, if it is not working fine, you will again report it back to the developer. So this is a simple kind of cycle. So I hope it is clear. So it is simple. When you are saying, suppose one device is there, one Cisco device is there, it is supporting 15 protocols. So all 15 protocol need to be go under this protocol testing. So generally what will be done, one protocol is assigned to one person, or 2 2 3 3 protocol is assigned to one person. So you have to pick one protocol and you have to test it thoroughly. And if you, while testing one protocol, you are seeing something is not working fine, something is not working fine, what you have to do, you have to report a bug. That bug will go to the developer. The developer will see, okay, out of all these functionalities of this protocol, this particular functionality is not working fine. So he will check his own code, like what is the problem, what I have done wrong that it is not working fine, and he corrects it. He tries to correct it, and after correcting he will send it back to you like, okay, now it should work fine. You will test it again as a protocol tester. Once you will approve, yeah, it is working fine, then that final code, whatever developer has corrected it, that will get submitted. So this is the normal life cycle. Now in OSI model, what we are discussing here is has total 7 layer of network communication, out of which data link and network layer are very important. See, in other layers also we have the protocols and we have the set of rules, but here, as I told, we are talking about mostly routing and switching. So mostly we'll discuss about data link layer and network layer. So data link layer means example of data link layer are Ethernet, MAC address, token ring, frame relay, etc. Network layer, example of network layer are available path in the network for communication between nodes. So IP address and you can say routing protocol also. So now we'll go to procedure of protocol testing. To conduct protocol testing, we require protocol analyzer and simulator. So when we'll say protocol analyzer, that is something which will help us to analyze the protocol. Analyzing the protocol, simulator, why we need simulator. So in the real-time environment, when we want to test a hardware, so hardware, first of all, it will come very costly. And again, as I told, suppose one device is supporting 15 protocols. So it is very difficult for, suppose 15 members are testing that hardware. Now 15, suppose one device is coming into some big amount. Now one device if you'll arrange, now 15 members, 15 into 1 means 15 devices you need. So it will increase the cost. bringing the device itself will cost a lot, so it will increase the budget. So in that case, simulator will be helpful. So what will be done? Simulator will be simulator is again simulator is created uh, by using software developers will create this simulator in such a way that it will exactly behave like a software. It will exactly behave like a software, and it will completely uh, whatever protocol or configuration you will do, it will behave, or it will give the same effect as a hardware will give. So that is where simulator is helpful. Now, protocol analyzer is used to ensure proper decoding along with call and session analysis. It is carried out by DUT to check the structure of the packet sent by the devices. So what this protocol analyzer will do, it will help us to analyze the protocol related things like packets uh, and packet related data. It will help us to analyze those things. So in that case, we need protocol analyzer. Simulator is used to simulate various entries of networking element. So there are various simulators we'll use. Generally, we'll use routers. Routers also will come into simulator mode, and for general purpose, in our home purpose, we'll use GNS and packet tracer software as well as a simulator. And other than that, in companies will use XCR traffic generator. That also sometime it can act as um, router switches. So we can say that also can act as simulator for us. So type of protocol testing. So protocol testing involves the following three checks: bandwidth, correctness, and latency. So bandwidth is rate of packet transmitted per second. So that will be in protocol testing. This bandwidth check is also involved. Correctness. So this is the, I should say, this is the first thing which is need to be tested. So it is tested to receive the expected packet for the intended protocol. So it's not only expected packet. There's a lot of things when we'll when we'll talk about correctness. For example, if we are saying like we are testing HTTP, so our packets are received expected, that will come in the second step. First step is our HTTP should be configured, and it should behave in a proper way, like what it should block, what it should uh, make into forwarding state, as we discussed it previously. We'll discuss it again. So first of all, its functionality should be fine, and then it should forward our frame or packet in the expected way. Latency: the time elapsed in receiving a data packet during its transit from the source node to destination node. So the time elapsed is latency test, that also involves into this protocol testing. Now is sub-classified into performance and functional testing. So performance testing, it covers the performance aspects of the device under test, such as stress testing, load testing, reliability testing. So stress testing means something which is like, for example, something need to support, for example, some device that it need to support 1000 VLAN. Now you are giving it more than 1000 VLAN, then we'll check how it is behaving. Okay, so this kind of testing is also involved into this. Then functional testing, it covers the behavioral aspect of the device under tests such as negative testing, conformance testing, interoperability testing, network feature testing. So this is one of the major testing, we can say this functional testing, because here only mostly will do big amount of testing here. And mostly when we'll call about protocol testing, this covers a major part, because here you can say network feature testing we are doing, how it should behave one protocol, how it should behave, various aspect of of a particular uh, protocol, negative testing, interoperability testing, how it behaves with a device of a different vendor. Okay, so this kind of testing is also involved, and this is the main thing. Mostly functional testing is covered, and it will cover the major part of the protocol testing. So in protocol testing, major part will be covered by functional testing. So this, we have just designed something. So operating speed of line to test the device operating speed at 100 Mbps. Say test case ID, test case name, test case description. So it is nothing. It is just a synopsis kind of thing, or you can say a high level view of a test plan. You can say what you are saying. You are saying the test case numbers, how many test cases you have decided, and test case name. So you will just keep a test case name and test case description, one liner description like what you're going to test here. So operating speed of line to test the device operating speed at 100 Mbps along with utilization of all available bandwidth to handle incoming traffic. So then protocol conversion rate, similarly negative testing, performance of telephone switch, spanning tree route path cost variation. This is nothing but a test case name, and you are giving a description what you are going to test. Okay, so I'll show you one uh, demo test plan also, just for your reference purpose. So um, this is a it is a just a demo test plan. So no need to worry about what is BVI, and it is just a function. It is just a protocol. So as I told you, it's like uh, a device will support numerous protocols, and individual have to test it. So that testing will involve, first of all we have to decide a test plan. So what will happen? I'll just tell you the overview and how it goes. So suppose person A has come up with a test plan for testing this feature BVI. Now see, you can see here BVI test case in the demo. Now you can see my cursor. So author is person A. Now date 22nd December 2010. Person B, person C, person D was the reviewers. So when you come up with something, others who have the good idea about this feature, they will also see your document. Here it is the test plan. So this BVI demo test plan, or that feature test plan, these people, person B, person C, person D, who are having knowledge of this domain or having some related knowledge of some particular protocols, they will also look into your test plan, and so those are reviewers. Revision point 3. What is this revision point 3? We'll see it down. So see, this is revision history. You can see revision point 3 version. It is showing version point 3. So what does it mean? Revision. Every time you went 3 times, so that person A has went 3 times for the review. So third time it is finalized. Obviously, when you are going to do something new, you will do some mistakes, or you will miss something, or you have to remove sometimes something. Okay, so that kind of thing will come with the discussion. So this is what we'll call it as version. So when this person A went first time on 27th October 2010, you can see the date. Okay, so what he did, he has come up with an initial draft. Okay, he has come with an initial draft, so he has just given the outline whatever he is going to do. Then in the second time, this person A went, so corrected typo, added few more functionality test cases. Okay, this was the comment he got. So person B, person C, person D has given this comment, correct typo, added few more functionality test cases. Then he went third time again, person A, and incorporated comment from that last review. Okay, so this is the way whatever you are doing, and as the review, whatever comments you have got, okay, so those things you have corrected, and after the review, whatever the point you have got, okay, that you have to mention here, and after doing that you have to incorporate it and you have to go again for the review. After getting review, again you have to put the comments, whatever comments you have got, and whatever changes you have done there as per the comments. Okay, so this is simple. Now as in the books we'll have table of contents, here also in the test plan we have table of contents. So you can see here document overview, topologies, configuration, references. So I'll just tell you the outline, high level view of this test plan. First of all, revision. uh, you came up with, see here, your test plan name. So it is demo VVI. Demo is demo VVI. So VVI is a protocol. Test cases. Okay. So who has written it? Who has written it? Person A has written 22nd December 2010. It was finalized. And how many time it got revision? 3 times. So 0.3 or 3 times also you can give. And reviewer was person B, person C, person D. And every time it got revision, who all have what all the comments given and what all things are incorporated. Then table of contents. So in table of content, it is equivalent to your index, what all things you are going to cover. So from this itself we can see what all things are covered here. So document overview. So you can see here identification, out of scope, limitation and assumption, feature overview, acronym. So what we'll see for example, for feature overview, when you are testing this BVI, so in BVI feature, suppose it is a big feature, and now you can divide into 5 different, this protocol also you can divide into 5 different functionality or 5 different sides of this feature. So you have taken one particular side of this feature. Out of these 5 sides, you have taken one particular side of this feature, and that you are going to test it thoroughly in this test plan. So in this feature overview, you will give that overview here. Okay, so that particular side of the protocol you will explain in the brief. It will not be a big description, it will be a normal description kind of thing. Okay, then limitation and assumption. So what all things are not covered here. Okay, those things you will tell. Okay, out of scope. Few things will not be will be out of scope here. Okay, so even though those are parts of our protocol, but in this testing, because of some limitation, we can't do it. Okay, identification, acronym. So whatever short forms and those things you have used in this test plan, those things you'll mention. It is similar like the books. Okay, not topologies. Like what are topologies you have used? Two routers connected. Okay, two router connected with two PCs. Okay, one router connected with one switch. So these things you have to decide by your intelligence and your teamwork and your experience. You have to decide it, and you have to tell how many topologies will be needed for checking all the functionality. See here, some 4 different topologies are needed. Okay, so this you have to come up. Then configuration. What is the configuration you have to do, that you will mention here. Okay, so the configuration. So this configuration will cover all the test cases. So in configuration also there will be multiple sub configuration, like for these many cases this configuration is needed, for other uh, for remaining cases this is the configuration needed. So that kind of thing we can mention here, like for first 5 cases we need this configuration, for another 5 cases we need this configuration, for this topology we need this configuration. So that kind of thing we can mention here. Now references. What are the references you have followed? Like generally what people will do, they will give their RFC names whatever they have followed. Okay, or some document whatever they have followed, they will give that reference name. Okay, after that they will decide what all test cases are there. Okay, so you can see here BVI test cases 5.1. So 5.1.1 is BVI configuration test cases, BVI functionality test cases. So there are various categories of the test cases. So you need not to worry what is this and what is BVI. That is just an overview. I just want you to understand what is the flow that is following. So you can see here identification when a frame is received on bridge instance. So they're giving just requirement and what is their benefit out of scope. What all things are out of scope. So BFD IPv6 are not in the scope of this document. Okay. So limitation and other requirement will be tested on SIU platform. Okay. Feature overview. Just giving a small overview. Okay. These are the short forms they have used. And here you can see SIU system. Okay. This is the DUT in the middle. So device under test. Okay. So it is simple. The configuration part, how to configure, will give in the detail, and test cases. Okay. Verify VI deleted or non-configure. Okay. How you will tell it is passed, test procedure. Okay, what is the procedure you need to follow, expected result. Okay, that's it. So this is the overview for the test plan, test cases. So here we have covered this particular section intro to protocol testing. So what is protocol testing? Types of protocol testing, and in the end we have seen what is a test plan, test cases, and what is the flow in which test plan is written and what should be mentioned there, what need not to be mentioned there. So those things we have discussed here. Thank you.